Hi guys, today I'm gonna explain about the flash memory and lower architecture and then the architecture and review our contents of the semiconductor engineering. Okay, let's start. First, we have to know about the flash memory. The flash memory is the very important in these these days. So is this slide shows the principle about the flash memory. As you can see in the slide, in flash memory, we storage the data on the floating gate in here. So this state is the oxide state. So there's some oxide barrier. There are some two types of the method to write the data. The first is the tunneling, and second is the hot carrier injection. So I will explain the two types of the method to write. First is the tunnel. If we set the source and drain the grounded, and if we apply the rush bias on gate, control gate, there will be some large big E field vertically in this area between the sub and gate and oxide, and this is the floating gate. So if we apply the large bias, the electron on the sub can be tunneling, so move to floating gate, and the data will be stored in floating gate. The principle is, I can explain this, the tunneling in this diagram. So if we the if we apply the rush gate bias, this this diagram will be the normal situation like this. But if we the gate bias highly, the slope will be will be like this. So as you can see in this diagram, the thin between this area is very thin. So the electron in here can be tunneling in this area. So this is the first principle of this is the first method of right, and second is the hot carrier injection. So if we apply the gate bias and drain bias, and the source is grounded, as we can see in this picture. If we apply the rush drain bias, there will be some effect, very powerful effect in lateral way. And if we also apply the gate bias, so there's some effect also. So in this area, there will be some hot carrier. So the electron have the rush energy can go through this floating gate. So we can bridge the data by these two types of method. And next is the how to erase in flash memory. As we can see in in this this picture, the erase method also use the tunneling. So 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 we can control the threshold voltage. So we divide the operation part, because if there's some if the floating gate have the many lots of electron, the the gate bias, if the gate bias want to make the channel, the gate bias have to push away the electron on floating gate. So if the data in floating gate, the VT will, the threshold voltage will be go over. So we can divide the VT high, VT low, or VT zero, or VT larger. So we can divide the between the threshold voltage. This, okay, I will explain about the how to divide the 0 or 1 or 0, 0, 0, 1 more like this. So if we apply the gate bias in the threshold read voltage, if there's some large current, we can know that this part is no data. But if there's some zero current, we can check this part is this floating gate have the lots of electron. So we can check the floating gate date by the offline, the read voltage. So this is the single level set because there's some 0 or 1. And if we see this red line, so there's some is 0, 0, 0, 1, and 0, 1, 0, and 1, 1. So we can, if we can control the VT and check the floating gate data, we can make the single level cell and advanced multi-level cell and also triple level cell. So this is the high technique about these days of the flash memory. So we can make the lots of state to control the VT and the current. So next is the device architecture to make the flash memory. The first architecture, also in device architecture, there's some two types. The first is the NOR and second is NAND. So simply, we can check the NAND architecture is smaller than NOR architecture. So in this industry, we usually use the NAND architecture because we have to make a lot of flash memory. So in our architecture, if we want to storage the data, we have to the word line bias and bit line bias, and this floating gate will filled with electron. So we can use the NOR architecture like this. And if we want to storage the data in NAND architecture, we have to apply the bias on all word on word line like this. So, and if we want to trap the data on word line 2 floating gate, we have to, so first we have to apply the all word line bias like this. And if there's some bit line bias applied, the electron can flow like this. And if we want to trap the data on word line 2, at the time we have to apply the powerful bias on word line 2, and there will be some effect, have the powerful effect. so the electron can be trapped in word line to floating gate. So this is the how to storage the data on NAND architecture. And as we can see in this picture, in NOR architecture, we have to make the contact on our junction. On the other end, in NAND, we don't have to make the contact on our junction. So in the point of view, the integration, the NAND is the very good way to make lots of the flash memory. So, but the lower architecture have the high speed, but the need to large area. But the NAND is the slower speed than slower than NOR, but NAND is the fast and also fast. So we usually using the NAND architecture because NAND architecture have the small need the small area. So we can make the in the same area we can make the NAND lots of NAND, but if the same area we can't make the lots of NOR architecture. So uh, and the one important point is the this state and this is the oxide. So have the oxide have the oxide barrier. So if we switch the electron on floating gate and if we cut off the or the bias, but the electron can go away from the floating gate. So the flash memory is the non-volatile memory. And before 1 week ago, I told the DRAM and SRAM is the volatile memory. So the SRAM and DRAM is the data can be deleted when the cut off the bias, but in flash memory, the flash memory is the non-volatile memory, so we can switch the data when there's when the bias will cut off. Okay, I think I talk about the flash memory, and this I think this is the my last video, so I was very happy and thank you for watching this video. See you later.